Hello friends, welcome back to my classroom. In this class, I'll try to explain how to find a fixed probability vector of a transition matrix and what is steady state probability. In a Markov chain, a fixed probability vector is a probability vector that remains unchanged after multiplication by the transition probability matrix. Suppose P is a transition probability matrix and V is a probability vector. Suppose when we multiply V and P, if it remains V, right? No change happened. In spite, even after multiplying P to V, the result will remain V itself. Then V is called as fixed probability vector or stationary probability vector. Hope you understood what is the definition of a fixed probability vector. And now let us understand how to find the fixed probability vector for a given regular stochastic matrix. So let us take this example. This is the matrix given P. P is the matrix given 3 by 4, 1 by 4, 1 by 2 and 1 by 2. Let us try to calculate the fixed probability vector V. Okay. So that V into P will remain V. Alright. So now since P is a 2 cross 2 matrix, the vector V should have two components. Okay. That's why I have taken V is equal to XY, two components. X is the first one and Y is the second one. And also since we are talking about probability vector, we know that sum of the components in the vector should be equal to 1. So X plus Y should be equal to 1. Okay, with these conditions, let us try to find V. Okay, finding V means we will try to get the values of X and Y here. Alright, so it's very simple. V into P is equal to V. So let us multiply V. V is XY and P is 3 by 4, 1 by 4, 1 by 2 and 1 by 2. This is our left hand side, V into P. And right hand side is V, which is X, Y. Right? So now let us try to multiply matrices in the left hand side. So XY is the first matrix, second matrix is this 2 cross 2 square matrix. So when I multiply V to first column has the numbers 3 by 4 and 1 by 2. So I'll get 3 by 4x plus 1 by 2y as my first component. And second component, I'll get it by multiplying it to second column. So 1 by 4x plus 1 by 2 is there. So 1 by 2y. This is the vector what I got after multiplying V and P. And right hand side, it's just XY. Now left hand side is equal to right hand side only if they are equal component wise. First component is 3 by 4 x plus y by 2 in the left hand side. And in the right hand side it is equal to x. And second component x by 4 plus y by 2, x by 4 plus y by 2, it's equal to y. Okay. And I have one more equation here which is x plus y equal to 1. So with this x plus y equal to 1, I need just one of these two. Okay, only one is enough. Right, because two variables are there. To solve two variables, to solve the equations with two variables, I just need two equations. One is x plus y equal to 1 is there. And among these two, what I got from multiplication of VP, I'll choose one of them. Okay, so I'll choose the second one. This looks little simpler. All right, so I'll take these two equations. One is x by 4 plus y by 2 equal to y, and the other is x plus y equal to y. All right, so by 4 plus y by 2 equal to y. X by 4 plus y by 2 equal to y. Alright, and the other one is x plus y equal to 1. So trick is very simple. I'll try to get one variable in terms of the other from the first equation and use it in the second equation. Okay, let me try. So x by 4 plus y by 2 equal to y. That gives me x by 4 equal to y minus y by 2. Alright. So this implies x by 4 equal to y minus y by 2. That implies x by 4 is equal to y minus y by 2. If I solve this, it will be 2y minus y whole divided by 2. Right? So this implies x by 4 is equal to 2y minus y, which is 1y divided by 2. Alright? So that gives me x is equal to 4y divided by 2, which means x is equal to 2 ones are 2, 2 twos are 4, so x is equal to 2y. Okay, so finally I could express one variable in terms of the other. Now what way I'll do is I'll use this in the second equation, which is x plus y equal to 1. So x plus y equal to 1 implies x, okay, x plus y equal to 1, okay, and this x is actually equal to 2y. Okay, so I'll try to get the equation in one variable. All right, x is equal to 2y, that is there in the box. All right, x is equal to 2y, so this x I'll replace it by 2y. 2y plus 1y is equal to 1. So totally 3y is equal to 1, which gives me y value is equal to 1 by 3. Alright, so y is equal to 1 by 3. So y value I got. Now I need to get the value of x. That's very simple because there is a relationship between x and y. So x is equal to 2y. X is equal to 2y. Y means 1 by 3. Y value is 1 by 3. X is equal to 2 into y. 2 into 1 by 3. Which gives me x is equal to 2 by 3. So I got both the values, value of x and value of y. Now my vector is ready. What was my vector? My vector was, fixed probability vector was xy. That means v is equal to 1 by 3 and 2 by 3. This is the required fixed probability vector. Okay, same idea is used in case of 3 cross 3 matrix, in case of 4 cross 4 matrix. Only thing, the number of equations will increase and we need to solve those equations. Alright, I hope you understood how to find the fixed probability vector of a transition matrix. Now let's understand, okay, how this helps me in finding the steady state probabilities. So for a regular Markov chain, this vector, alright, this fixed probability vector represents the long run proportion of time spent in each state independent of the initial distribution. Suppose I have a transition matrix of a Markov chain, and in the Markov chain suppose I have two states, let's say A1 and A2. Okay, suppose these are the two states A1 and A2. Now once I find the fixed probability vector xy, the value of x gives me the proportion of time spent in state A1 and value of y gives me the proportion of time spent in state A2. Okay, so to understand better, suppose 100 days are spent. Okay, maybe I got v is equal to 0.7 and 0.3, let us say. That means out of 100 days, 0.7 of 100 is 70 days. 70 days are spent in state A1 and remaining 30 days spent in state E2. Okay. So let's uh, try to get the better understanding with the real life example. Okay, I'll take the same example what I had used in higher calculating higher transition probabilities. Each year Arjun trades his car for a new car. If he owns a Nissan, he trades for a Honda. If he owns Honda, he trades it for a Toyota. If he owns a Toyota, he is equally likely to trade it for a Nissan, a Honda or a Toyota. Now I want to calculate in the long run how often he will have Nissan, he will have a Honda and he will have a Toyota. Okay. To solve this, again we just need to find the fixed probability vector of the transition matrix of this Markov chain. So let us write the transition matrix of this Markov chain first. And for the complete explanation of how to write a transition matrix of a Markov chain, you can visit to my previous lectures. I have given the link in the description box. Okay, for this example, let me try to write the transition matrix P. So I have three states. One, he can have Nissan or Honda or a Toyota. Nissan, Honda or a Toyota. So three states are there. So it's a 3 cross 3 matrix. Okay. If he owns a Nissan, he trades it for a Honda. If he owns a Nissan, he trades it for a Honda. So Honda value, Nissan to Honda is 1. Nissan to Nissan is 0. Nissan to Toyota is also 0. And second line says, if he owns a Honda, he trades it for a Toyota. Suppose this year, if he has a Honda, next year he will have a Toyota. Honda to Toyota is 100% sure. So one is the probability. But if he has a Toyota this year, he is equally likely to trade it for a Nissan or a Honda or a Toyota, any one of them. Okay, so 1 by 3 is the probability, because equal probability for all the three, and sum should be equal to 1. So 1 by 3, 1 by 3, and 1 by 3 is the probabilities. All right. This is the transition matrix for the given Markov chain. Now to calculate the long run probability, we need to find the fixed probability vector of this transition matrix. And what is fixed probability vector? Again, V is said to be fixed probability vector if Vp will give me back V. Right? Okay, so let us try to find V here, fixed probability vector. Okay, so this is the transition matrix what we got, and here since it's a 3 cross 3 matrix, I'll have three components in my fixed probability vector V, and sum of the components is x plus y plus z equal to 1. So already I have one equation to calculate the values of x and x, y, z. So x plus y plus z equal to 1 is my first equation, and I need two more equations. Right. So what I'll do, I'll take V into P is equal to V. Let me have V here. So V is x, y, z, and P is 0, 1, 0, 0, 0, 1, 1 by 3, 1 by 3, and 1 by 3. And right hand side, of course, it's just V. So it is x, y, and z. Right. Now I'll multiply these two matrices. When I multiply it with the first column, I'll not have any x because it's 0. I'll not have y. I'll have only z. So it is 0x plus 0y plus 1 by 3z. Okay, that's the first component. And in the second component, I'll have 1x because the first row value is 1 and last row is 1 by 3. So 1 by 3z. No y there. So 1x plus 0y plus 1 by 3z. And the last equation, x into first value is 0, so no x, but 1 y will be there. plus z by 3 is equal to right hand side x, y and z. Right. So I'll have the equations. First component I'll match with the first one. So z by 3 is equal to x. Okay, here straight away I got one variable in terms of other. Z is equal to 3x. Okay, and second equation is x plus z by 3 is equal to, second component is y, and second is done, x plus z by 3 is equal to y, and the third one is, actually I don't need the third one because I already have this one equation here, second equation and the third equation. Alright, three equations are enough. Okay, so I will go with these three equations. First one, let me remember, z is equal to 3x, z is equal to 3x, and second equation is x plus z by 3 equal to y, x plus z by 3 equal to y, x plus z by 3 is equal to y. Okay, and the third equation is the main one, x plus y plus z equal to 1, where I substitute other variables. Right. So z equal to 3x, one variable is expressed in terms of the other. That's okay, I need not simplify further. Only thing, second equation I have to simplify. X plus z by 3. Z is 3x. I already know it is 3x by 3 is equal to y. So what does it imply? X plus 3x by 3, 3 by 3 is gone. X plus x is equal to y. Which means my y is equal to x plus x, which is 2x. Right. So two equations, from these two equations I got the variables z and y in terms of x. Now it's very easy. So these two things I have to substitute in the last one. Okay. So I know that x plus y plus z equal to 1. I'll have x plus y, I take it from here. Y says it is 2x, and third one is z. Z says it is 3x. X plus 2x plus 3x is equal to 1. So that means totally 1x plus 2x plus 3x. 1 plus 2, 3, 3 plus 3. Totally 6x is equal to 1. That means x value is 1 out of 6. Alright, 1 by 6. Now getting the other values are very easy. Alright, so y is 2x. Y is equal to 2x. 2x, x is 6, 1 by 6. So 2 divided by 6. And third one, z is equal to 3x. 3 into x, x is 3 by 6, or you can write it as 1 by 2 also. Okay. So we combine all the three and get our fixed probability vector v. V is equal to 1 by 6, 2 by 6 and 1 by 2. So this is the fixed probability vector required. Okay. So what is the interpretation? 1 by 6 and 2 by 6 can be written as 1 by 3. Okay, that you can change it to 1 by 3. 1 by 6, 1 by 3, 1 by 2. 1 by 6, 1 by 3, 1 by 2 is my fixed probability vector. Okay. So interpretation is this: about 1 out of every 6 years he will own Nissan car. Okay. If the habit is as per the Markov chain here given, so whatever may be the initial distribution in the first year, whichever car he might have, but in the long run, 1 out of every 6 years he will have Nissan, because it's 1 by 6. Alright. So second component is for second state, which is for Honda, 1 by 3. That means 1 out of every 3 years he will have Honda. Or you can understand like this: if 30 years, if he if he follows his habit for 30 years, almost 10 years he will have Honda. Alright. And finally 1 out of every 2 years, more frequent. Okay, so about 1 out of every 2 years you will have a Toyota, right? So this will be the interpretation. Okay, so now I hope you understood what is fixed probability vector, okay, and what is its application in real life examples. And this with this I'll stop the topic Markov chain, okay, and in the next class I'll start with central limit theorem, and moving forward I'll explain uh, the application of central limit theorem in evaluation of probabilities, in finding the confidence interval, and later testing the hypothesis. All right, thank you.